Chapter 14, Exponentials and Logarithms. And the first part of this chapter deals with exponential functions. Now, an exponential function is of the form a base, which in this case I've called a, to the power of x. So let's look at what the graph of y equals 2 to the power of x will look like. We'll just do a simple table of values to work out a few points. Let's go from -3 to 3 on the x-axis. So 2 to the x, 2 to the power of 3 is 8, 2 squared is 4, 2 to the power of 1 is 2, 2 to the 0 is 1. If you notice, it's halving each time as we go backwards, so half, a quarter, an eighth. Now if we were to plot that, the graph would look something like this. Now, a graph of this type should be quite familiar to you because of COVID-19. It's one that shows exponential growth. This side, we say this is a horizontal asymptote. It's asymptotic to the negative x-axis. It never quite reaches the x-axis, but gets closer and closer and closer to it. What about different types of exponential functions? We change the base. So let's change the base to say 3 to the power of x. Well, 3 to the power of x will get closer to the x-axis more quickly, but will rise more steeply. If we reduce the base, say y equals 1.5 to the x, well, that will take longer to get to the x-axis, or the negative x-axis, and will rise less steeply. What about then y equals, say, a half to the power of x? Well, a half is 2 to the -1, so that's 2 to the minus x. So if we say our base function f of x is 2 to the power of x, and we know what that graph now looks like, then a half to the power of x is f of -x, because that is a half to the power of x. Now, as types of transformations, inside the bracket, so it's all about the x-axis, all about the horizontal. It's a horizontal flip, so it reflects through the y-axis. So that one would look like so. Still passes through 0, 1. So that one would be something that's getting smaller and smaller and smaller. And we often say that's exponential decay, something that's losing value. So it could be like something like the value of a car as the years pass. Okay, that actually covers all of example 1. Now move on to example 2. And it wants us to draw the graph of y equals half to the power of x take away 3. We know the general shape. It's going to be something to do with a half to the x. It's going to look something like this. It's going to be worth working out where it crosses the y-axis, and it's going to cross the y-axis when x is 0. That's a half to the -3, which is the same as 2 to the 3, which is 8. So it's going to cross the y-axis at 8. If we think about types of transformations, if we start off with our base graph being a half to the x, because we know what that looks like from the last example, something like this, except go through 1. Well, all we're doing here is swapping x for x take away 3. So we've got f of x take away 3, which if you remember from work on transformations of graphs, that's going to be a translation 3 to the right. Horizontal because it's in the bracket. If you remember the line story, if you're in a cage, you're awkward, so you're going to shift 3 to the right, not as you'd expect 3 to the left. So if we shift that graph 3 to the right, it'll look something like so. It won't ever go below the x-axis. That graph's a little bit dodgy. but the general shape of it will look like that. Okay, and that's all of the examples for the first part of this exercise. So if you now have a go at exercise 14a, and see how you get on with those.